Greetings and welcome to IT SPARC Cast Top 10. I'm your host, John Barger.
And I'm your host, Lou Schmidt. Let's get to the countdown.
In IT SPARC Cast Top 10, we go through the top 10 things, events, or people in a specific category. We then give you the details that you might not know with insights, opinions, and a little sarcasm from two experts, each with over 20 years of experience working in IT or for IT vendors.
Some of this you'll maybe know, some of this you won't. I didn't. I think the fun of making these episodes is digging back into this and finding out where everything came from.
Absolutely. So in today's episode, we're counting down the top 10 most influential operating systems you never heard of. These are operating systems that you may or may not have had commercial success, but their development had key advances that led the industry forward into where we are today. For this top 10, it was hard to rank them by importance, so we listed them in order of their release date. In a few cases, if they didn't actually get released to the public, it was based on their publishing of papers or other documentation. Now, we've actually excluded some that you may think should be on this list. For example, we did not talk about Next Step because many have heard of Next Step, which then led to the acquisition by Apple and became the current Apple operating systems that we all know and love today. But
you could argue that was an actual commercial success.
100%. So if we missed any of your favorite obscure yet influential operating systems, let us know. Send us email at feedback@itsparkcast.com or hit us up on X. And now to the countdown.
Let's do this.
So at number 10 is CTSS, or the Compatible Time Sharing System. This is from 1961. This was first demonstrated at MIT in 1961 on a modified IBM 709. It entered regular use in 1963 and operated until 1973. So this was an actually used operating system, and it ran on two different IBM 7094s. They were named Blue and Red, respectively, and these were done to support more users. So that's why they ran on two different systems. These were developed, again, by MIT, by Fernando Corbato, and Project Mac team. Now, that is not Mac as in the Apple Mac system. So in addition to Fernando, there were some other key contributors. There was Robert Fano, Marjorie Daggett, and Robert Daly. And this was back in the days when an operating system like this was done by a small core group. And as we get a little farther on, you'll see larger and larger teams get involved. This was used by early computing pioneers, including the infamous John McCarthy.
Dun, dun.
Now, it's when it comes to its contributions and influences, it was the first practical time-sharing operating system, hence its name. It enabled multiple users via multiple terminals to access it all at once. It introduced shell interfaces, early text editing, and one of the very first email systems. So no matter what you hear from somebody else, email has been around for a very, very long period of time. It also inspired the use for virtual memory, user directories, and secure file access. So way, way ahead of its time for the early 60s. These things were brand new and really unheard of at the time. So from a historical significance standpoint, this was the direct cursor of Multics, stand by for that, and the inspiration for Unix, which we all know and love. It is the basis for many of the operating systems that we use today. It validated the concept of interactive multi-user computing, and it laid the foundation for OS concepts used in modern systems today. So prior to this, it was really the wild, wild west. A lot of the operating systems that were used at that time were hodgepodge, didn't have a lot of multi-user systems. They were, a lot of times, were just switches that were being flipped. This was the first one where you had a terminal, multiple people could log in. It was really advanced for its time.
I mean, think about it this way as well. This was a computer prior to microcircuits, right? Microcircuits didn't come along till later. So this was a whole hodgepodge of transistors. And in those days, you maybe didn't even have an operating system. If you had a special use machine, everything was dropped in machine code, and you would execute the jobs you needed to execute in machine code. So I think this was a pretty big breakthrough. Multi-user, the concept of being able to come in with a terminal was pretty big.
Absolutely. All right, let's bring us to number 9, Lou.
Let's go into number 9. And this, I got to say, was one that I did not know about.
I did not know about this one either.
I did not know about this one. So it's called Atlas Supervisor, which is Manchester Atlas OS. And this was in 1962. So it was developed alongside the Atlas supercomputer from 57 to 62. So in the early days, well, up until fairly recently, to be honest, operating systems are evolved in concert with the hardware they're going to support. I would argue the biggest break from this was probably Linux, but because it sprung out pretty early. But up until then, you had hardware and software you were targeting. This was created by the University of Manchester, and it was led by Tom Kilburn, developed in partnership with Ferranti Ltd, and it influential on later OS researchers like Per Brinch Hansen. So what did this thing do? It was the first system with paged virtual memory. So if you play around with operating systems much at all, you realize how important this is. Usually in an educational environment, somebody will go, oh, I've got a ton of memory, I'm going to turn off virtual memory or whatever, right? And then everything explodes and they're like, okay, that was a bad idea. So this thing really was the first system with paged, being able to swap pages in and out. It also enabled multitasking and concurrent job execution, and it introduced job priorities and automatic restart on failure. That was new, right? If a job failed, it didn't assume the program was bad. It could assume that there was a hardware problem somewhere or something, restart it, try it again. So it was the blueprint for modern OS kernels, virtual memory and multiprogramming, influenced design like Multics, IBM System 360, and Unix, and regarded as the first modern operating system. Now that's interesting. I've never heard of this, but it's the first modern operating system.
That's amazing.
That's pretty cool.
Yep, it's got a place in our list.
Let's find out what else it influenced. John, you've got number 8.
You bet. So number 8 is IBM OS 360 from 1966. So this is a big one, and a lot of you may have actually heard about this one. This was actually the oldest operating system that I've personally used. I actually did use this a bit in college, and it has legacy all the way up till today. So this was first announced in 1964, and its first major release was in 1966. And it has evolved through multiple variants of IBM operating systems from MVT to MVS and up through ZOS, which is currently running today. And Lou did some research, and we believe there's at least a couple of 100,000 still in operation today, really running our banking systems. So if you're doing a financial transaction, there's a good chance some of that's running on the successors of this system today.
It's hard to overstate how important this one
100%.
is.
And not only that, but this was the system that introduced virtualization via the CP67 in the late 60s. Matter of fact, go back and watch the very first top 10 we did on the top 10 technologies that are older than you think, where we talked about the hypervisor and virtualization. This is the system that started that in the 60s. Most of us thought that virtualization started in the late 90s or early 2000s. This was the system that actually started that. So from a people and organization standpoint, again, obviously this was developed by IBM, by Fred Brooks and Gene Amdahl.
Where have I heard of Amdahl before?
Amdahl, very interesting.
They went on to do some really interesting stuff.
He did. And this was documented in a story called The Mythical Man Month, which was really a documentation of this whole timeline of the development of this and many other systems. It was a massive undertaking. It involved hundreds of contributors over many months of work. This was really unprecedented for its time. It was the first massive project to bring an operating system to commercial use. And now this is not unusual to have hundreds of developers working on an operating system to bring it out. But at the time, this was really unheard of. This was really the first standardized operating system for a specific hardware family. And again, revolutionary for its time. And it pioneered what's called JCL, or Job Control Languages, which allowed for spooling and other robust I/O subsystems. I remember using JCL when I was in college to be able to control when my systems got printed. So we would actually write our code. We wouldn't get our output on the screen. We'd have to wait for it to print. And I had an upperclassman actually teach me some JCL code that actually put my a queue up in front of others, so I would actually get my printouts faster. But that's a whole story for another day. And as we mentioned earlier, it also introduced hypervisors and virtual machines as part of the CP67 and the VM370, which was that virtual machine that we talked about. From a historical standpoint, it really cannot be understated. It dominated the enterprise computing space for decades. It set the standard for system design, project management, and virtualization, and it was an ancestor for nearly all of the IBM enterprise OSs that are still in use today. This was a big one.
I mean, I gotta say, I think IBM is still selling mainframes. I remember when I looked into this like 10 or 15 years ago, and the ZOS system, which is sort of the great grandchild of this, is still going strong, because I can't think of anything more bomb-proof than a mainframe for virtualization and sheer input-output capability.
And even if they're not selling new ones, they're definitely selling maintenance contracts and parts for systems that are currently running.
Yeah, so if you haven't seen this one, it was a big deal. Also, the Mythical Man Month is pretty much required reading if you're in software development and some areas of management. If you manage engineers, it's required reading. And if you look back at some of the other failures in OSs like Pink and the other operating systems that we talked about, they're same sort of effort, right? Even with IBM involved, but they failed. And I've seen a lot of these failures. So let's move on to one you might have heard of, but this one's another big one. You ready for this?
Lucky number 7.
Number 7. Number 7 is Multics. And Multics was first developed by MIT, GE, and Bell Labs starting in 1964. And it ran on the GE 645 mainframe in 67. And the final shutdown of this operating system. When did it get shut down? 2000. Year 2000 is what shut this thing down. So it hung in there for a while. The team was led out of MIT by Fernando Corbato. I believe I pronounced that correctly, but Bell Labs and GE. Pay attention to that middle part because it's going to come up later. It inspired Fred Thompson and Dennis Ritchie to create Unix, which was another Bell Labs project with Berkeley. And it also continued by Honeywell and Boole after GE's exit. So it pioneered segmented memory. So the idea that you don't have to resort your memory and make it contiguous, you could put this thing all over the place and grab holes. That was pioneered by Multics. Dynamic linking, you use dynamic libraries, dynamic linking, it was started here. Security rings, which is also a very, very important concept in virtualization, is there, and it's in everything now. Introduced hierarchical file systems and fault-tolerant hardware support. So imagine, before Multics came in, everything was in the root directory, right? You didn't have directories. We don't even, I can't even conceive of this.
I mean, you don't keep all your files on the desktop? That's what I do. Everything's on the desktop.
Oh my God. La, la, la. Anyway, we were just having a big security discussion. So anyway, it introduced hierarchical file system, and it was the very first OS to earn a B2 security rating. So first one to get a security rating. It influenced Unix and all modern OSs and historical segmented, pushed the boundaries of secure, scalable, multi-user systems, and its legacy lives on in ring protection, file systems, and kernel design.
It's another big one.
Yeah, that was a lot of the basics of how you do a kernel were really hashed out on this thing.
Yeah, absolutely.
And that's a big one. But let's talk about something that I actually touched this one. I touched it, but I didn't touch it much. And that would be number 6.
Number 6. And I actually have a bit of a personal connection to this one as well. So number 6 is the TOPS 10 operating system from 1970, designed for the DEC PDP-10. So this was originally developed in 1964 as the PDP-6 monitor, and then it became TOPS 10 in 1970. It was active up until the early 80s with the PDP-10's end of life, and it was superseded later by TOPS 20 from DEC Systems. Little personal notes, The gentleman who was the lead developer on TOPS 20 was named Dan Murphy. Dan Murphy worked with me and reported to me later at a small startup that we were at called Certion, and he was one of our lead developers there. He's a great guy. And Dan, if you're listening, looking forward to maybe catching up with you sometime.
Good job,
really
dude.
Had good times. Yeah, but he used to talk about the good old days working at DEC and working on TOPS 20, so that was a great time. Back to TOPS 10. This was, again, developed by DEC, the Digital Equipment Corporation. It was influenced by the contributions from MIT, Stanford, and BBN, which is Bolt, Brannick, and Newman, which was, no matter what Al Gore said, they were the ones that actually invented the internet. And they were the foundations for the early ARPANET development. From the contributions and influence, it enabled true time sharing for hundreds of users. So this had massive scaling capabilities. It supported early networking and email. And BBN was actually one of the first open email systems. They developed email for many users, and it did inspire hacker culture and open source sharing. So this was actually a big deal and really inspired a lot of people. From a historical significance standpoint, it was the platform for ARPANET and the early internet software. This influenced user interfaces and command line design, things like MS-DOS. MS-DOS wouldn't exist without having been influenced by the command line interface here, and was just groundbreaking from its impact on user-centric computing and networking in general. So TOPS 10 was big from that standpoint, and we owe a lot to it.
This is another one of those things. The PDP was another very foundational computer. And
100%.
I would not be at all shocked if somebody's still actually using them in production somewhere.
Now, I'm jealous because Lou gets to talk about number 5, and it's something that I'm a big fan of. So go ahead and bring us in with number 5, Lou.
Well, I got to say, number 5, you should break in where you want. But number 5, I would call this one as another huge one, Xerox Alto Executive, which was in 1973. And really, this was built at Xerox PARC, and it was launched internally in 1973. And it never commercialized, but it was widely used in PARC and selected labs. Now, if you've heard us talk about this before, we've talked about the mother of all demos, right? Where the mouse was first shown, windows and menus and stuff, the graphical user interface was first shown. This is the child of that demo. And it was, so it was done by a Xerox PARC team internally, Lampson, Thacker, and Kay. It was inspired by Engelbart's NLS and Plato. It was demonstrated to Apple in 1979. Okay, we're on Apples right now. This is a descendant of that operating system that you probably never heard about, right? What was it? Well, it was the first GUI-based OS, Windows icons and mouse. It introduced WYSIWYG editing and Ethernet file sharing, right? Well, they had to wait until Ethernet was invented, but that came later, right? But it introduced it. It was the precursor to desktop metaphors used in Windows and Mac OS. So we've sort of screwed around in this area, but we keep coming back to these things. That's how well they work. And the historical significance of this is they set the blueprint for personal computing. They nailed it so good that even though we can do all these different things, we keep coming back to it. It inspired the Macintosh and modern graphical interfaces. So I would say X Windows is another thing that really came out of this, which had heavy input from PARC, if I remember, PARC and MIT.
Yeah.
And it's legendary for being decades ahead of its time. This came back when you talk about the Apple lawsuit against Microsoft for user interfaces. This is what it came back to.
Yeah.
Right? Somebody else already had it.
If you took a look at this interface, you would actually think it was something from the 80s, the mid 80s, not something from the early 70s. It is really that advanced comparatively, and it's really impressive. And what I found interesting about it is that it was more of a portrait screen than a landscape screen like we're used to today, but that looks more like a piece of paper. So that's what they were going for, is they were trying to make it truly like you were working on a piece of paper in true WYSIWYG, where fonts and what you see is what you get, which is where that term came from. So this was light years ahead of its time. It's unfortunate that the hardware really didn't allow it to sell at a reasonable cost that people could afford and get out there. We could have been 15, 20 years ahead of where we actually were from a computing standpoint if this could have actually been commercially viable.
first series of Macintosh computers were pretty expensive.
Yeah, absolutely.
I remember that. But I have to say, if you're watching us on a desktop, you're running a derivative of this interface.
100%. 100%. Now, speaking of something that you're running a derivative of, brings us to number
absolutely,
4.
this one's huge, and you may not even know it.
That's absolutely right. So number 4 is CPM, or the Control Program for Microcomputers, from 1974. So this was created by Gary Kidall, and it became dominant as the 8-bit operating system in the late 70s. It started to lose ground after IBM decided to go with MS-DOS in 1981, and was gradually phased out by the mid 80s. So again, originally developed by Gary Kidall for digital research, and was licensed to dozens of different microcomputer vendors, and it missed out because of the IBM PC popularity. And it really was a race of what was going to end up running on those IBM PCs. Was it going to be MS-DOS or was it going to be CPM? And they ended up going with MS-DOS. And but really MS-DOS was that next generation, that derivative of CPM. At the end of the day, MS-DOS did win and continued on through. And we'll talk about that when it comes to the historical significance. But obviously, MS-DOS was inspired by CPM with commands, file structures, and so forth. CPM was also the introduction of BIOS and BDOS. So what we've seen today, a lot of computers still use BIOS today. BIOS is the ability to go in and set hardware settings so that when you boot up, it has certain instructions. That's still in use today by a lot of computer systems, and this was the first set for that. From a historical standpoint today, it was the foundation of the PC software industry. So we wouldn't have things like MS-DOS and Windows and other modern operating systems if it wasn't for this. Again, direct ancestor to all of that. And it created the first cross-platform ecosystem for personal computing. So hugely foundational and a big deal. And if you don't know much about it, you should go look up CPM because it was. And
it really was. The whole idea of a standard BIOS didn't come along until later. I made my first ever digital circuit on an IBM PC AT. No, it was a PC. Yeah, it was a PC AT. It had a 286 with the BIOS, the IBM BIOS. And I don't think most folks don't realize how big a deal BIOS was.
Yeah.
You could actually do everything in BIOS. I wrote a driver in assembly that did everything in BIOS. You didn't even have to bring up the OS. And that was the thing. So let's talk about another major step that we took here. Are you ready for this one? Number 3?
Yep.
Number 3, VMS, the virtual memory system that came out in 1978. So you know how we talked about the PDP series of computers being foundational to the early internet? This was the other part. So this was the follow-on. The VMS launched with the VAX mini computers in 1978, and it was renamed to OpenVMS in the 1990s. It was ported to the Alpha chip, which was a commercial failure, but an absolute architectural gem. So absolutely, the parts of that live on in the AMD processors. Itanium, which was from Intel, and x86. And it's still used today in critical systems. VMS is really bomb-proof. So it was created by DEC, led by Dave Cutler. Cutler later developed the core of Windows NT at Microsoft. So if you're watching this on a Windows computer, all Windows computers now came from VMS, which is a good place to come from. If it didn't have Win32, you'd have been in much better shape, but I digress. What it did, though, that was really important is it introduced clustering, fine-grained security, and advanced scheduling. So as this whole internet thing was coming up, people were finally starting to push jobs in remotely. Advanced scheduling got to be a really big deal because you could have more users, more multitasking. Instead of running a process batch scheduler, you could do this all dynamically. It inspired the Windows NT architecture. It's known for its stability, uptime, and robust user management. John, my first ever exposure to the internet was through VMS.
Nice.
First thing you did when you got to Slack, after you sort of got oriented on the machine, is you got your first email address at slack.stanford.edu, and that was on a VMS system. So you read net news and your email on the VMS system. And yes, that thing was really, really bomb-proof. So its historical significance sets standard and high availability computing. This and ZOS are the two big ones.
Yeah.
I mean, Linux, it's gotten there to a point, I think, to be really, really, really reliable. But I would run a cluster of 3 of these if I was running this. It was the direct influence on modern Windows. The core architecture of modern Windows came from EMS, and it's still trusted in environments requiring absolute reliability. They have beat all the bugs out of this thing.
No doubt.
It is insane.
Yeah. So these have all been like, every single one of these have been like core to like the development of operating systems going forward.
Now, I have to admit my pain. I handed you number 2.
You did.
And I was such a fanboy.
And I think this one's going to be a big surprise for a lot of people. And a lot of you may have heard of it, but they're going to be surprised it's on this list. Number 2, AmigaOS from 1985. Now, I'm going to qualify this as that when Amiga was popular, I was an Atari ST guy. So I was on the opposite end of the thing. And if Lou and I met each other on the streets, we would have, well, it probably would have been a slap fight. It's more than a gang fight, but it would have been that. So AmigaOS was originally released with the Amiga 1000 in 1985. It evolved through multiple generations up through the 3.x series before Commodore eventually went bankrupt in 1994. It continued through various hobbyist activities and third-party updates. Its current variants are in the 4.x line.
Yes.
It was originally built by the Amiga Corporation and sold to Commodore, and its key contributors were Carl Sazerath, R.J. Mikal, and Dale Luck. It inspired passionate developers and user communities. You might be wondering, why is this on our list? So it was the first multitasking operating system on a home PC. So when we say this, preemptive multitasking, prior to this, you had multitasking, but the schedule inside the PC would say, I'm going to work on this, and then I'm going to start working on this. With preemptive multitasking, it was truly scheduling and working on things in real time, and you wouldn't actually see the difference. And that was really revolutionary for the time. Now, Lou will tell you that it had its other problems, and it had memory issues, and these things could really collide into each other. And so I'll let him get into that when we get there. But it really did have some really amazing capabilities. It had a really amazing combination of GUI, CLI, and multimedia support. This was known as a multimedia powerhouse, and there were many video editors and real-time video broadcasters that were using the Amiga systems out there. And there were many times I would see, especially things like your public broadcast television stations,
your local access cable, right?
Your local access cable operators. Late at night, you might see them reboot the Amiga, and you'd see that pop up. And
Crew
then
meditation error.
Right, absolutely. And it was the influence for a lot of different OS designs in for good and bad when it came to the UI, and then when it came to audio and video handling. So from a historical significance, it really was years ahead of its time, as many of these operating systems have been. It was, especially when it came from its inspired expectations for multitasking desktops. It popularized multimedia capabilities because at that time, you had a lot of monochrome systems that for graphics. The Macintosh was almost exclusively monochrome at that time. The Atari system, if you're doing design, was monochrome or very low res color. So this was really the first system that really provided really robust graphics. And it really did have a cult status among developers, and today, retro computing fans, if you mention Amiga, they just have this love in their heart for it. And I see it even when I talk to Lou and I talk to others, that it really does inspire a lot of love.
I mean, to be honest, it was, from a technology perspective, for something whacked up in Los Gatos, California, which I used to live right down the street from. The investment was made by a bunch of orthodontists. That's where Amiga came from. And Commodore up and bought it. Commodore is the poster child for how not to run a business.
Yeah.
Right. And I watched this whole thing in real time, but what always blew me away about it, despite the fact that you could get memory corruption because it didn't have a memory manager, which went back to the way that Motorola 68000 microprocessor was designed, you needed a separate memory management unit. These guys were too cheap to do it. But the fact that it kind of spun in right around the time we all watched it, it was a very, very active net news group on this where the engineers were always on it. But it all spun in at the time. The idea of having multiple screens, the pull down desktops, workbenches and stuff, you could get something like it on X Windows with virtual windows, but getting at the same time, but getting X Windows required like Sun workstations or IBM mainframes, right? You couldn't afford this. Mac did not have virtual windows at that point. That came later. So that was a really huge thing for organizing your work. I like to think a lot of that ended up hopping over into the Linux community because you can still actually get a window manager was based off these concepts, and it's called Enlightenment, and it's still in active development. So if you want to play around with something like that on any Linux box, you can pull it down, run it
Nice.
in VM, or yeah, it's pretty neat stuff. Are
All
you
right.
ready though?
We are ready. You mentioned Linux. Let's go a little bit farther back.
Wow. I mean, this one is really interesting. So let me tell you a little story about a guy named Dr. Andrew Tannenbaum, who I first came in touch with in my networking education. Number one is MINIX, and it was developed in 1987. So if you have a computer science education, you've probably heard of this. If you don't have a computer science education, you probably never heard of this. MINIX was created by Andrew Tannenbaum for OS educators. It was first released in 87, and it inspired Linux. All right, so it lives on in MINIX 3 and embedded systems like Intel ME, which sits inside as a little tiny core operating system inside of Intel firmware. All right, so this was developed by Tannenbaum for his textbook. Now, Tannenbaum's sort of famous in the networking and the computer science world. If you read his networking book, which I highly advise you do if you're in networking, it tells you why there's 7 layers in the OSI model. John, do you know the answer to why there's 7 layers in the OSI model?
Makes a great burrito.
7 committees. It's all about politics, right? So that's one thing I've always loved about Tannenbaum, is he gives you that viewpoint into how this stuff works. But he built this operating system, which a lot of people were playing with, people were trying to extend. Then one of his, well, by his telling, not the best students he's ever had, kid named Linus Torvalds, you may have heard of him, used that as the basis to write Linux. So what happened here, right? Linus Torvalds took Tannenbaum's class and decided he got a 386 computer for Christmas, but he couldn't afford Windows. So if Bill Gates had a time machine, he would probably go back and give Linus Torvalds everything he asked for. And you never have to worry about competition from Linux, right? Because Linux kind of won overall. It's in everything. But really, what did MINIX give us that's continuing on, which kind of owns our life, right? All of our architecture is pretty much based on Linux now. It was the first accessible Unix-like OS with full source for learning, right? You could get BSD Unix before or around this time, but there was a huge legal fight between Bell Labs and Berkeley that was going on that really held us up. If that legal fight hadn't happened between AT&T, Bell Labs, and Berkeley, probably would all be running BSD. It's good OS, it just got hung up by the licensing. So Linus comes along, gets a 386 that doesn't have an operating system, or has DOS, right? And says, what am I gonna do with this thing? Takes Tannenbaum's MINIX, writes a whole operating system based on it. So what did MINIX bring him, right? It taught him about microkernel architecture. showcased in fault isolation, sparked the Linux development and OS architecture debates, educated generations. This is still a very powerful educational tool. You have the full source code, computer science student can break down everything that this operating system is doing. If you're going to write a compiler, which is why Linus Torvalds came to the United States, he wrote the compiler for Transmeta and their very long instruction word processor. This is how you want to start. And the embedded version is very quietly running in millions of Intel chips. So if you jump into like the offline interface, like during the boot sequence, when you see all that stuff coming down your screen on a server, it says get into this Intel NIC to configure stuff. Yeah, that's MINIX.
That is.
So, wow, huh?
Absolutely. So that's going to cover this episode. And we couldn't do this podcast without listeners like you. We want to hear what you think. Which of these was your favorite operating system that you actually did hear about? What operating system did we miss? Which is a niche operating system that had a huge impact that we missed? What other topics do you want us to cover? Are there other top 10s you want us to investigate? Send email to itsparkcast.com. That's feedback at itsparkcast.com, or hit us up on X at itsparkcast. If you're on YouTube, you can leave us a comment down below. We read every single piece of feedback we get, whether it's on YouTube, X, or on email, and we respond to almost every single one. Please make sure to hit like, subscribe, and turn on notifications. That's really going to help this channel grow. If you feel that you're getting value out of this podcast, if you're getting entertainment and value, please tell your friends, tell your colleagues so they can get the same information that you're getting. With that, we're going to turn you back to your day. We'll see you soon with more information from the world of enterprise IT. Take care.
Thanks for coming along with us.